Hello everyone, you are learning physics from Uncle Irodov, and in this module we will be having a look at Irodov's 1.5. This is a very simple problem. There are two particles 1 and 2 which are moving with constant velocities v1 and v2, and initially from a certain origin they are at r1 and r2. These two particles should hit each other after some time. What should be the condition on v1, v2, r1 and r2 such that they are able to hit each other after a certain amount of time? Clearly, for the particles to hit each other, they should be at the same place at the same time, which means R final for the first particle should be equal to R final for the second particle. But R final for each of the particles can be obtained using their velocities. For the first particle, the displacement is equal to R final minus R initial, which is equal to velocity into time, which means for the first particle I can write R final is equal to R initial plus V delta t. So using that equation, I can find out R final for the first particle, which is here, and R final for the second particle, which is here. And their equality would mean that I will have R1 minus R2 is equal to V2 minus V1 into t. Now, this could have been the answer as well, but this is not the way the answer has been presented in the book. Now, an equation of this kind, which has vectors on both the sides, says that the vectors are of equal magnitude and they have the same direction. Equality of directions would mean that the unit vector along r1 minus r2 should be equal to the unit vector along v2 minus v1. So finding out the unit vector along r1 minus r2, I will get r1 minus r2 divided by modulus of r1 minus r2, and the unit vector along v2 minus v1 is v2 minus v1 divided by modulus of v2 minus v1. And equality of these two unit vectors is then the condition that the particles will hit each other. So hoping that you have learned something from this and you will be coming back for more videos of mine.